Hello everybody, I'm Kalyani Adawadkar. I belong to Department of Information Technology, Sigma Institute of Engineering. Today we'll be seeing a topic called asymptotic analysis. So let us see what is asymptotic analysis. Asymptotic analysis is a mathematical model which helps to analyze the algorithm with respect to the input size. So asymptotic analysis is basically input bound, and if there is no input to the algorithm, it is concluded to work in a constant type. Other than input, all other factors are considered constant. Now, to analyze asymptotically the algorithms, there are basically three notations: big O notation, omega notation, and theta notation. Each of them is used for a different purpose. Let us see them one by one. First of all, the big O notation. It is a formal way to express the upper bound of an algorithm's running time. It measures the worst case time complexity, or the longest amount of time an algorithm can possibly take to complete. Let us see it with the help of an example. Here you observe that there are two curves which are drawn. One is with respect to a function fn and another is with respect to a function gn. Now this curve, what you will observe is this particular curve is crossing each other. These two functions are crossing each other many times, okay? But after a point n0, what you will observe is the value of g of n is always greater than f of n by a constant, say c. So up to n0, g of n may or may not be less than f of n. But after this point n0, g of n is always greater than f of n with its constant c. So how do we interpret this? We say that f of n is equal to big O of g of n if there exists a positive constant c and n0 such that f of n is less than equal to c into g of n for all n greater than equal to n0. Let us see it with the help of an example. Let us say f of n is equal to n square and g of n is equal to n factorial. Now if we put in the values, if the value of n is 1, f of n is 1 and g of n is also 1. If we say n equal to 2, f of n is 4, okay, g of n is 2. If we say n equal to 3, f of n is 9, g of n is 6. But when we say n equal to 4, 4 square is 16, f of n is 16 and g of n is 24. So after the value of 4, g of n will always be greater than f of n. So g of n is an upper bound on f of n. So what do we say? F of n is equal to big O of g of n for all n greater than equal to 4. The next notation is the theta notation. The theta notation is the formal way to express both the lower bound and the upper bound of an algorithm's running time. Now, if you see in the figure, we have got this function f of n, and what you will observe, in some cases, f of n is greater than a constant into g of n, and in some cases, it is less than a constant 2 into g of n. So basically it lies between these two, c1 into g of n and c2 into g of n for higher values of n which are greater than or equal to n0. So how do we interpret this? We say f of n is equal to theta of g of n if there exists a positive constant c1, c2 and n0 such that c1 into g of n is less than or equal to f of n is less than or equal to c2 into g of n for all n greater than or equal to n0 and c1, c2 greater than 0 and n0 greater than or equal to 1. Okay, let us see how to understand this with the help. Now let f of n is equal to 4n plus 3 and g of n is equal to n. What is the statement we have made for a theta notation? The statement that we have made for a theta notation is c1 into g of n is less than or equal to fn is less than or equal to c2 into g of n. Now let us see, when the value of C1 is equal to 1 and the value of n is greater than equal to 3, just calculate this 4n plus 3. So if you substitute the value of n is equal to 3, you get 4 into 3 plus 3. 4 into 3 is 12, 12 plus 3 is 15. And what is the value of g of n? Let us see what is C1 into g of n. C1 is 1, g of n is n. Okay, so what is the value of n we have taken? 3. So 1 into 3 is 3. So the value we had got over here was 15, and 15 is greater than equal to 3. So this particular statement is true. Okay, this part is true for the value of n greater than equal to 3. We have checked it with n is equal to 3. Now let us say this value of C2 is equal to 5, and for any n greater than equal to 3, let us calculate the value of this for n equal to 3. 4n plus 3 is what? 15 again. Okay, and let us see what is C2 into g of n. C2 we have taken as 5. C2 we have taken as 5 and n is 3. So 5 into 3 is 15. So 15 is equal to 15. It is not less than 15 but is equal to 15. So this condition is also true. So we can say that if fn is equal to 4n plus 3 and gn is equal to n, then fn is equal to theta of g of n. Means g of n is a tight bound for f of n. Next, we will see the omega notation. The omega notation is the formal way to express the lower bound of an algorithm's running time. It measures the best case time complexity, or the best amount of time an algorithm can possibly take to complete. Let us see the diagram over here. What you will observe is after this, as you increase the value of n, after this n0, you will find that the value of fn is always greater than that of gn by a constant c. In such cases, we say that fn is equal to omega of g of n. So fn is equal to omega of g of n if there exists positive constant c and n0 such that c into g of n is less than equal to f of n, or you could say f of n is greater than equal to c into g of n for all n greater than equal to n0. Let us see it with the help. Example, f of n is equal to n factorial and g of n is equal to n square. We have seen that for a value of n is equal to 4, n factorial will always be greater than that of n square. So we say that f of n is equal to omega of g of n, indicating that g of n is a lower bound for the function f of n. So this was about the asymptotic notations big O, omega and theta. Thank you.